Welcome to another video from Lockdown Electronics with me, Bill, and this time we've got a review of a multimeter. It's the Kaiweets KM601 smart multimeter, and Kaiweets have sent me this free of charge to review. The only thing they've asked me to do is mention the name and the serial number a few times and put that also in the description, which I would do anyway. So I'll just give you my honest opinion of this, and we'll see what it's like. But it's a multimeter, and these days even the cheapest multimeters are usually amazingly good. You know, when I think back 40-50 years to when I was a young lad playing with electronics, I had a very ancient and very inaccurate analog meter, and I was delighted if I got a measurement that was within, you know, the width of the needle. So most modern multimeters are actually excellent, and I've no doubt this will be too. So what I'm going to try and do is focus on the kind of things the electronic hobbyist might use it for, particularly milliamps, millivolts, AC current and DC current, because I think they're the kind of things the hobbyist tend to use, and I suspect this meter is aimed mainly at hobbyists. So let's make a start and look what's in the box. And the first pleasant surprise I got was the meter comes in what looks like a very nice carrying case. There's also a multi-language manual, and it's very well written. It's clearly been translated by somebody who is familiar with English. I can't speak for the other languages, but certainly the English translation is very good and makes complete sense, which is a pleasant change, I find sometimes for this Chinese tech. So what have we got in here? Well, obviously we've got the meter here, which we'll come back to in a moment. We've got various accessories. We've got a set of probe leads. We've got 6 AAA cells and the thermocouple for temperature measurements. So the meter actually needs 3 of these batteries, so it's nice to get a spare set. That's a pleasant surprise. So we'll get on and fit these and then see what she looks like. So we've got thermocouple and we've got a pair of leads. They seem to be reasonable enough quality for a meter at this price point. Got blanking caps in the plugs there to plug into the meter, and the tips have got what looks like removable covers. Yeah, they have. There you go. So you can be nice and safe there if you're working on high voltage and leave the covers on. I always leave the covers on unless I specifically need not to. So right, we'll get that connected up. So we'll switch on, and I'm guessing, yeah, common is there, so it's given me a flash of lights there to tell me common, and this one here is for pretty much everything except current. That socket is milliamps, and then the 10 amp range. So we'll go into the more general socket, and currently it's hopping round trying to read whatever it is that's it thinks is on the end of the probes. So we'll get a few things to try that out. Okay, so remove this soft plastic protecting boot from around the meter, and there are 3 Phillips head screws on the back. The most obvious one would seem to be this one, and removing that allows you to lift up and get access to the battery compartment there. So as I've already mentioned, there's 3 AAs clearly labelled with polarity, so we'll just pop those in like so, and then it's making a beeping noise, so I'm guessing that I've managed to get them the right way around, and so it's booted up, and yeah, there we are. It's come on straight away, and there is an on-off switch on the top. I'm guessing that a long press turns that off. Yes, it does. Right, while it's off, just going to check that is properly tight. Yeah, I'm going to pop it back into its protective sleeve. which I think is probably quite a nice thing to have. Save it from getting damaged by the rough and tumble of knocks when it's in use. Okay, so that's the beastie, and one press of the top switch there brings it on. It boots up in smart mode. Okay, so that's the basic setup of the meter. So we'll switch that off and we'll take a look at the leads. Okay, I've removed the protective boots from the probe tips so I can attach some bulldog clips to the leads here. So I've got negative lead connected already, but I just want to show you how this works. It's hopping round between ohms and volts and AC and DC, and it's obviously searching for whatever it thinks is attached to the probes in auto mode. So I'll now attach that, and fairly quickly it's now telling me DC 3.291 volts, and if I turn up the voltage on the supply, we're now up at about 10 volts, something like that. And yep, there she is, following the volts reasonably accurately, I think. So what I'm now going to do is I'm going to get my bench meter set up and see if I can take some simultaneous measurements. I'll just get set up so that you can see both displays. Okay, so a quick look at DC current. So we've got a strip of LEDs here just fed from the DC power supply, and the 2 meters are in series with those LEDs. Currently just got them lit, and we're showing 2.6 microamps here and 2.6 microamps on the east tester, so that's pretty good. I'm going to just gently increase the voltage. I'm going to go up to about 20 millivolts, something like that. So just let them both settle down, about just over 20 on the yeah, they're tracking within 0.1 milliamp, so that seems pretty good. We'll just go up a little bit more to about 50 milliamps, something like that, and just let them settle down. about 51.1, and again both meters are green, so DC current appears to be pretty good too. So if we drop that right down, so the LEDs are just about lit, sort of there, and we're at about 0.03 milliamps. That's saying 0.05 milliamps. I maybe need to change scale on that to get a sensible reading. Yeah, there you go. So 0.05, 1.49, yeah. So it's pretty good measuring small DC current. Okay, just looking at AC current now. So I've got the Kaiweets KM601 attached in series with the east tester, and then I've got an LED here, and the AC source I'm using is my signal generator just set to 100 Hertz, and they're both correctly that's correctly identifying the frequency. Interestingly, the east tester hasn't picked up the frequency yet, so I'm just going to up the voltage, and hopefully you'll see this LED down here get a little brighter as I do that. So I'm going to go up to 8 volts peak to peak, and yeah, both agreeing fairly closely there. 6.1 milliamps. Let's go up to 10 volts peak to peak, and we're now getting 9.7 on the Kaiweets, 11.7 on the east tester. And if we carry on up to about 15 volts, which is about as bright as I want to get that LED, because I'm likely burn out if I go much further, 26.6 on both instruments. So there's obviously a little discrepancy down around about 10 volts, but well, actually they're pretty much agreeing now after having said that. So AC current, yeah, does a good job. Okay, a quick look at capacitance then. So I've got it set to in capacitor mode, and in the middle of the range here, this is 100 nanofarad polyester cap. Yep, that's pretty close, and it does say nanofarads there. It's probably not quite so easy to see. At the far end of the range here, I've got a 420 picofarad, and that makes it about 0.4, so 400 picofarads. So that's within 5% of the stated value on the component, and that's actually outside the minimum capacitor range. So actually, that's pretty good. And then an electrolytic, we've got a 220 microfarad here. Make sure I get the polarity right. Just takes it a moment to settle. It's now changed to microfarads, and it's saying 211 as opposed to 220. So yep, think that's pretty good. These ranges, particularly capacitance and resistance, are the kind of thing the hobby electronics user would want. So it's pleasing to see that that's doing well there. Okay, we'll have a little look at resistance. I'm not going to spend too long on this. Modern digital multimeters are usually excellent at resistance. So I've picked the two extremes that I've got in my component stocks here. So first of all, I've got a wire wound resistor, which I recovered from some equipment a while back. I've measured this with my LCR meter. Comes out at 4.79 ohms, so it's a very low value. 4.79 is what the LCR meter makes of it, and the Kaiweets is making 4.5 ohms. Now, considering the LCR meter was using a 4-wire measurement method, and obviously this Kaiweets is using only 2, I think that's pretty good. And then finally, a very high one here. It's supposed to be 8.3 megohms. I've measured it on the LCR meter as 8.06 megohms. So let's see what it makes of that. 8.06 on the LCR meter with 4 wires. On here it's coming out at about 8.02. So again, those are the two extremes, and it's done fine. I did check a couple of resistors in the middle of the range, and not surprisingly, it was perfectly okay. Okay, so here we are attached to the signal generator, looking at frequency. So I've got the machine set to frequency, and it's records the frequency in large digits, and this is the duty cycle underneath. I'm currently using a sine wave, and so 50% duty cycle is reasonable, I would say, in that case. If we hop onto square wave, we can have a look at how that duty cycle performs, and I'm going to just alter the duty cycle in 10% steps. So that's, according to the generator, that's 40, 30, 20, 10, and then I'm going to go 89.9. Sometimes instruments struggle when the duty cycle is quite large. That's pretty respectable. So that's 80, 70, 60, and back to 50% duty cycle. So yeah, that does pretty good in terms of frequency and duty cycle. Let's now up the frequency. Let's go straight up to 100 kilohertz, and as you can see, the display's changed to there to 100 kilohertz, so that's tracking that perfectly. Let's go up to 500 kilohertz. Yep, still there. We're back on sine wave, by the way, and we'll go straight up to 1 megahertz there, and the display is now reading megahertz rather than kilohertz. So we've got a 5 megahertz. See if it keeps track of that. Yeah, it is. What about 10? Yep, so there's 10 megahertz. I reckon that's pretty close. Let's try 15. Oops, no, sorry, completely made a mess of that. Let's try 15 megahertz. Yep, there we go. It's certainly agreeing with that. And let's finally try 20 megahertz. Yeah, that's okay too. What I've noticed is that Once you get to 22 megahertz, that's as far as it goes, but having the ability to accurately measure frequency up to 22 megahertz like that is pretty good. And I think, you know, these days it's easy to take this kind of thing for granted, but I've been playing with electronics since I was a kid, and this is a level of measurement and accuracy that I could have only dreamed of back then, when we were happy if we could get a measurement that was within the width of the needle on the analog display. So to be able to measure 22 megahertz like that is pretty good. Onto the diode function. So I've got a conventional silicon diode here, so this is reverse bias, and not surprisingly it's saying 0, which is good. Just swap that round and see if it tells us what the forward bias voltage is. 0.601, which I should say is reasonable for a silicon diode. Let's just pick another small signal diode and see what it makes of that. So that's reverse bias. Let's swap it around. 0.618 forward bias, so it's correctly identifying the silicon junction temperature. I'll just do one more. And that's 4.449 forward bias, and reverse bias is not surprisingly 0. And if you're thinking why is that a bit low, that's because it's a germanium diode. So diode check is good. Okay, I just want to try and show you what happens when you do change ranges. And one thing that's really nice is if I take the lead out, it knows that the lead is out. If I pop it in there, it knows when I've inserted the lead in there that we need milliamps, and if I put it in there, it knows that we need amps. So that's actually really nice. I didn't realise it automatically changed ranges. I should perhaps read the manual a bit better. So lead means pulled the lead out. It's a vagary of the English language that lead also means lead in English, but hey, you know, English is a bit like that, I'm afraid. So it's worked out it needs milliamps there. So let's put it back in the, shall we say, the common socket, the one it spends most of its time in, and we're now going to hop around to continuity, and you can see the LEDs flashing there reminding you which sockets you need to use. And I often see people doing multimeter tests, and I think they expect miracles and instant response from the continuity, and I think very expensive meters probably do give you that. But this one, if I touch that on there, also getting an indication green LED at the top. I actually reckon that's probably one of the better multimeters I've had doing that. So that's continuity. Okay, well that's a look at the Kaiweets KM601 smart multimeter. Would I recommend it? Yeah, actually it's pretty good. I think I'll probably make use of this. It's quite a handy little meter. Feels nice and solid. Pleased with the way it works. I particularly like the fact it's very easy to hop between auto and manual. I suspect I shall use the manual range more than I will the auto, as it allows me to choose what I want to measure. But yeah, that's okay. If you've come to watch the video because you're thinking of buying one of these, there's a link in the description to the Kaiweets shop. If you use that link to make a purchase, that helps me a little bit. I don't make any money from the channel, and anything I do make will go straight back into it. So yeah, if you'd like to consider using that link, that'd be absolutely great. And if a few of you do that, I'll make sure that anything I do make goes straight back into the channel. Hope it's made some sense, and if you get one, I'm sure you won't be disappointed. Thanks very much for watching. Thumbs up if you've liked it, thumbs down if you haven't. Either way, please consider subscribing. That doesn't cost anything and it really helps me, and we'll see you on the next video.